Hello everyone, welcome to Programming Knowledge. So I again welcome you all to Programming Knowledge. So in today's tutorial, we are going to continue with the core techniques in our series. So today we are going to implement two things. First is we are going to before that I would like to say that this is our GitHub link, and you can move to this GitHub link of our GitHub link, and you can find all the codes implemented in Python prior to this tutorial. So let's start with today's tutorial. So in today's tutorial, we are going to implement first, this is the GitHub link, and we are going to implement two pointer in unsorted array and binary search. So first we are going to implement find a pair whose sum is equal to target k, but here the trick is this array is unsorted. So in the previous tutorial we did this with a sorted array, but today we are going to do with an unsorted array. So second is implement a binary search in a sorted array. So we are going to implement our code in the notebook because it gives a better understanding, and plus if there is an error it's easier to debug rather than again if there is an error then I had to run the whole program again, so this would keep a clear structure and maintain the flow. So let's implement binary search first. So we'll define binary search. So I'll put a comment here: a is equal to list. So A is the list, and key is a target value. So binary search is a search operation which is basically performed on a sorted array. So binary search can only be implemented on a sorted array. This is the key, and this is the prerequisite to the binary searches, and it takes time complexity of log n. So it takes a time complexity of log n. The space I'll define in the next line: space complexity is equal to log n if it's recursive, and it is space complexity is space complexity is of 1 if iterative, in case of iterative. Okay, so the recursive calls are due to stacked data structure. So this is the big difference. You need to figure out why if we do it recursively and if we do it iteratively. So the prerequisite is that it should be a sorted array, but another is it should be if it's a recursive then the space complexity becomes O of log n, but if it's iterative then space complexity O of 1. So let's implement our binary search now. So we are going to implement it iteratively because most of the question you do it iteratively. So we define binary search. So we are going to define binary search, and we'll take array as a parameter, left pointer, right pointer, and a key. So now we have a array, left pointer, right pointer, and a key. Now the first thing in the binary search we do is calculate a mid. But before that we would loop while left less than is equal to right. We calculate a mid pointer which is left plus right by 2. So we calculate the mid if a of mid is equal to the key, then we return mid. This is the case if the array of mid is equal to key, then we return the mid. Else we check for two conditions. This is the elif part and else part. So we look for the two conditions in the elif part and else part. If we find, then we return the index. If we are able to measure, then it's fine. So how we measure? Either we compare if array of mid is less than key. Here you can assume that the key is greater than array of mid. So we define left is equal to mid plus 1, because we are trying to now assume that we are approaching towards the key. Because if we want to approach towards the key, so we have to increment the left pointer. Okay, else this is a case where key is less than array of mid. This is an opposite condition to this one. The key is less than array of mid. So we are assuming that either you can say that array of mid is greater than key, or key is less than array of mid. So we decrement the right pointer. Right pointer is equal to mid minus 1. If we don't find any index, then we return minus 1, assuming that that we don't have a key in the array. So let's do it for our test case. I would copy this and I would paste it here, and now I would return my function binary search of a. A is a point 0 comma len a minus 1, because and then key would be our my key would be this. Now let's assume. So here you can see, now I have a index 0, 1, 2, 3, 4. So perfect. So I have a array in which 200 is at the uh, 200 is at the fourth index, so I can return this index. That's perfect. So let me show you how we can do this uh, inbuilt function in Python. You can do this using inbuilt function in Python. I'll show you. Do one thing. Go to import bisect. Okay. Now you need to simply call bisect dot bisect underscore left, and simply pass these parameters. I'll tell you. One is this array comma key comma 0 comma len a. There's a slight difference. You see a comma key comma 0 comma len a. Now you call this function. You can see here you get 4 as the output here. So this is the inbuilt function which works as a binary search. So this is inbuilt. So inbuilt. So that bisect. I'll write here bisect acts as a binary search. So this is the that this is a bonus for you because it acts as a binary search. Let's move to our next question. So we need to define a I'll show you the test case. So here you can see k is equal to 17, but please note this is an unsorted array. Please, this is an unsorted array and k is equal to 17. So I need to define two targets, 10 and 7. So k is equal to 17. So this is k is equal to 17 is our target, but which is the fulfill which two elements which make a pair as a target sum is 10 and 7. So let's do it for the this question. So I have an array, and I'll call a function find target pair, and it would take array and k as a target. So I'll define the function find target pair now, which takes a array and k is a target. So I'll also put this in our comment. A is a list and k is a target value, and I'll make sure that this is unsorted list. I hope now this is fine. Now I can implement my function. To keep a track, I'll take an unordered data structure that is set. So the lookup type in average is O of 1, because since it's an unordered data structure, you can also use a hash map here. For I in range len a, I'll define a complement. If first I'll define a complement. Complement is equal to k minus a of I. This is complement. Complement is the target minus the target value minus array of I. So this would give me the complement. If complement in set, so if the complement exists, because complement plus a of I would equal be k, because complement is k minus a of I plus a of I is equal to k, then I would simply return complement comma a of I, else If it's not there, I'll simply add set dot add a of I. So let me run my function. Simply, you can see two points are 10 comma 7 are the 2 points which we had required. So this is how we look like binary search. We also implement two pointers as binary search, that is left and right. So this is a good example. I showed you how you can do it, one thing on sorted array, and this is the inbuilt view of the binary search. The next is for unsorted array. So thank you guys, thank you so much for this tutorial. I'll catch up in the next tutorial. So thank you guys, thank you so much.